Let me show you. There is one more command where you can get the both these adjusted odds ratio and crude odds ratio in one single interface. So we'll see that. Let me open this data. So could you guys do some practice yesterday after getting those like recording or probably the data file? Yes. Okay, I think I have not shared my screen probably. Okay, BMI calculation went wrong, the way I saying. No worry, it'll be, so after this calculation, could you correct it, Divya? Okay, so you can share your screen in the breakout room today, and then probably they will guide you where you like maybe in the multiplication, or you have to make the denominator in bracket, otherwise it doesn't take. So probably they'll help you out, all the facilitator in the breakout room. So have you joined with the laptop? Like, okay, Dr. Sumana is saying like she was able to do. So probably you there many times we also do some error occurs and then you keep on like correcting that error, then it automatically gets corrected. So I'll before we go to the breakout room, I'll show a few more things. The first is the interpretation. So if you see this was the model, final model. We have shown you the hierarchical sort of model yesterday where I was entering the variables one by one. And we have just shown the improvement in AIC and BIC and R square as seen by this table. That and then Venkatesh also asked regarding the, how we can see the different, this model. Like here you can see there is a drop down. If you see this model specific result, this is the drop down of this model 1, 2, 3, and 4, 5. So if you keep on clicking, you will get the result of specific model. And then we discussed like these are the two different table. This is the likelihood ratio test, which is the chi-square test, and it shows the predictor variable, the significance of predictor variable. And this is the this is the p-value of wall test. So what this Z is also known as the wall statistics, and this p-value is derived from this wall. And we have seen that this estimate, whatever you see here, that's the actually the log odds. And when you like make it as exponent, then this odds ratio is the exponent of this estimate. And we have calculated also using the calculator.net regarding taking E as a base, calculating the odds ratio. We have also seen regarding the various assumptions, we have checked for the collinearity diagnostic, and we have again checked for the this values of the residual predicted values and the Cook's distance. So these three we have seen in the data set, it appears, and we have seen like Cook's distance should be less than 1. So, and all the values were less than 1. So now how to present so before I go for the presentation, how to write your result, there are various ways of writing the result. It depends the number, like what is the space and also what all detail you want to show. But basically, either you can do one thing, like many authors, they don't show the adjusted and unadjusted both. So if you just want to write about the unadjusted in the write-up, then you can show this as an adjusted one. This table, you can just right click and copy paste it. You can modify it a little bit. And again, giving all the values of like Z, P, and the 95% confidence interval. The interpretation will be like, how do you want to interpret? Do you want to interpret as a percentage or you want to interpret as an odds? So like, let's say we were discussing about this gender. So the odds ratio of this gender is 0.35. So you can say that the odds of surgery cancellation was less in female. How much less? So in less, if you have to express it in percentage, you like deduct this 0.35 from 100. So 100 minus 35 will be 65%. So there was a 65% less odds in the female, the surgery cancellation odds in female as compared to male. And if you want to present like odds, then you can say like odds of surgery cancellation was 0.35 times as that of male, means it was less, cancellation odd was less in female as compared to male. Similarly, if you want to compare like age, since age is a continuous variable. So for continuous variable, how do we interpret? So we say that 1 unit increase. So basically here we say that 1 unit increase in the age or 1 year increase in age leads to the change in the odds ratio, means not change in the surgery cancellation. So if I have to express it in percentage, I will again, what I will do, 100 minus 99, so 1%. So there was a 1% less, that means the 1% a less chance of the odds of this surgery cancellation was 1% less if you increase the age by 1 year. So in case of a continuous variable, we express like this if you want to express it in percentage. In case of categorical variable, we take the reference, and again, either you can express it in odds or you can express it in percentage, taking the reference category. And in the interpretation, you have to write the assumptions also. So for that, I will show you. Before that, there is an option which is this PPDA. Can you see there is a module, this PPDA, which calculates the both these unadjusted odds and the adjusted odds. Many of you who have downloaded this. Okay, PPDA was for this. Sorry, it was for ROC. So for yes, so many of you, if you have not downloaded this, because this doesn't come as a basic module, so you go and download this. This PPDA will download it on the day of ROC. This comes from survival. In the survival, there is a survival module, and how to identify that. So there is a plus sign here. If you go here in the JAMO, you can see that there is a plus sign, which is there for the modules. So for extra module, you have to click this, and then it shows you what are the, in the library, what are the installed module and what are the module which are there in the library. So if I have to go to the Jamovi library, it shows you the installed versus available. So I will here write like survival. It is a clinicopath survival. Even if you don't write clinicopath, if you write survival. So there is a death watch survival. You don't have to do this, because if you do this, this comes first, but you have to download this one, this J survival module for the clinicopath for Jamovi. This you have to download. And since it is already installed, that's why in my this thing it is writing installed, but in your case, if it is not installed, then you have to install that. And then you go and click on this survival. And then you can see in the survival, there is a odds ratio table and plot. So if you click this odds ratio table and plot, then all variables you can enter it here. You don't need, like, there are no separate windows for the covariate and the categorical variable. So I will enter all the variable. Like right now, yesterday we have seen that I removed 2 or 3 variable like chronic diseases and all, but right now I'm entering just for demonstration. I'm entering all these variables. And in here, you have to first the categorical variable. You have to enter this surgery status, which is my dependent variable. So my dependent variable is surgery status, and then all other variable. So let's see, I will move this age, gender, then this BMI. BMI was not significant. Chronic disease was also not significant. So admission type, anesthesia type, and then days of the week. I'll just show with the surgery type. And then you can see here that it gives you the odds. It gives you a 2 by 2 table also. Like you can see here, it gives you like what is the odds of cancellation in female and the male. This column is for done and this column is for cancelled. Again, it gives you all the categorical levels, also like male and female, and then this OPD, IPD, general and regional, and the emergency and planned. And here it gives you like both the adjusted and unadjusted. So this odds ratio is univariable. This is your unadjusted odds, and this is your adjusted odds. So you can see here p-value, this is significant. Initially only this age and this admission type, and these were significant, and that's why you took this in the final model. Here what you can do, since I have removed two of the variables, so what you can do, like you can include that variable also and show that since in unadjusted it was not, p-value was not significant, that's why you did not take that. And in the adjusted one, there will be a dash for that particular model, because in adjusted, you will not take that. Like here, what you can do, generally what we have seen, that here that you take the chronic disease also. The one was BMI. So I have included BMI and chronic diseases also. And then you duplicate this table. So I will wait because then it will take some time. Okay, probably BMI I have not, there is some issue with that. Maybe I have not.
The chronic disease जो है ना
Just a sec.
वेरिएबल नेम से
Which so chronic disease.
chronic underscore disease होगा.
So I'll have to go to the data variable now and change this. But yesterday it was working.
But chronic disease we are not talking.
No, but I showed it. Like yesterday it was like not significant. So I just removed it from the final.
Then it will run. वेरिएबल टाइप पे यहाँ डिपेंड करता है. Sorry, आइटम पे.
That's okay. Then we should correct that now. Let me do that. Dr. Shamshad is saying since there is no underscore, so I'll put the underscore here in the chronic disease. That's why it is not coming.
Space.
That I'm doing. Now let's see. So chronic disease, if right now, if now I enter. So yes, that's why you will see that there is a underscore in all these. So now you can show that since chronic disease, if you see it, it is not significant. So in unadjusted, you can show this, but for adjusted, you will not take this in the adjusted model. So you will duplicate this, you will copy paste this table at one place, then again remove this, chronic disease, and then you will perform. And then you write this multivariable odds ratio. Because for final model, you are not going to give this chronic disease and BMI because these were not significant. So we did not include these variables in the final predictor model. But for unadjusted, you have to show each and every variable. Or else what you can do, like you can write in the write-up that unadjusted, you don't give the unadjusted and you only give the adjusted. The way we have seen here without using this, this option of J survival, only this table. You can take a call of giving this also as a result, but we have written this one, we have taken this output from this J survival path, and we have written the same which you have seen here, and this is the interpretation. So in the interpretation, you have to write about the assumptions also. Like what are the assumptions? And after testing the assumptions only, you have moved for making those models. So yes, can someone read this interpretation of this? We will share all these. I think we have shared these templates also with you people. There are, again, we are saying that there are various ways of presentation. It's not the only way, but again, you will see that in various articles, people have presented this differently, the way they want to show. So can someone read this interpretation? So I'm not, we are not writing here the hierarchical one. We are only giving the write-up of the final. Again, if you wish to write about the hierarchical nature, like how you have entered all the variables in the model, that also you can do. But for simple, if you see, for people like us, if we are not doing very advanced sort of analysis, then this is okay. This much, like entering all the variables together after checking the unadjusted odds. Of course, that is needed. That you cannot escape. That is the must. And checking the assumptions is the must. Now, entering all the variables together or one by one. Because if you are doing it one by one, then you might see that, you will have that AIC, BIC, and deviance, which you might not see if you don't increase, I mean, you don't do the hierarchical nature, like one by one, which we have seen yesterday. Am I making myself clear to all of you? Can someone say something? I mean, message or chat. Priyanka is writing yes.
Ma'am, good
Good afternoon, Anuradha.
ma'am, good afternoon. Ma'am, now the last point you told me about AIC, BIC, just fast, I couldn't get.
Okay, I was
Could you
just
please
telling
repeat?
this. Remember, we discussed about this AIC and BIC. That you see the improvement. So if like you can, because there is no, like generally, if you only give one value of AIC and deviance, it doesn't make any sense. So either you can then, if you want to show superiority of your predictor variable model, then you can use this hierarchical where you can show that there was an improvement. Otherwise, even if you just give one value and you write this, because overall model test, this is important, that it is significant, 0.001. And if it is significant, then that means there is an improvement over null. Means null model is when there is only intercept, there is no predictor. And predictor, if there are predictor, then definitely if this is significant, then it tells that your predictor model is better than the null model. And again, this R square also, again, we discussed yesterday that this R square is different from the R square in the linear regression. In linear regression, if this would have been how we would have explained that the variance in the variation in the dependent variable, which is the surgery cancellation, is 14% variation in the dependent variable can be explained by these predictor. But this is not the interpretation in case of logistic regression, because here it is based on probability, and that's why they are known as pseudo R square, the McFadden. It is not the true R square. So they just represents the improvement over null model. So how I will write that there is a 14% improvement over the null model, seeing the value of McFadden R square. So did you get, Anuradha, what I was telling, like regarding these model fit statistics?
And yesterday we talked about that R, how to put the correct R square type. I mean, McFadden.
You asked now, like which do we use this R square? So it is all, if you click that.
Am I audible?
Yeah, you are audible. Can you repeat it again?
Yeah. Yes, ma'am. How to use the criteria for using the different pseudo R square?
Criteria for using different?
Am I audible?
You are audible,
R
but
squares, pseudo R squares. Which one to choose and when?
okay, yes, you said yesterday you were also saying that
Which
Nagalkar.
one to choose and when?
So actually, all the three options are there, and various authors, they have said, like someone is writing, if you see the SPSS doesn't give you the McFadden. It gives you the Cox and Snellen and Nagelkar. So McFadden, I'm not going into the detail, like he has given it the calculation, how it is calculated. They take deviance and variance into account and they calculate the R square. So, according to the recent literature, they say that Macfadden is the best. Now we don't use like Cox and Snellen and Nagalkar. So, Macfadden is the best to use. Situation, I don't know, like situation, there is no such situation where you can, given in the literature that in such situation you should use Nagalkar and in this situation you can use Macfadden. There is no such thing available. If maximum what you can do, you can see the difference between these R square. Because if you click, yesterday also we saw that if you click the Nagalkar, it shows 20% improvement from the base model. From the like 0, if you see the value here, where here it is the 14. So it is more conservative. That means what is said, that they other values are more kind of more inflated. The Nagalkar or Cox Snellen. Macfadden is conservative. So if Macfadden shows that it is significant, definitely the Cox and Nagalkar is going to be significant. So that's why you report, it's better to report only Macfadden, because I'm clicking this Cox and Snellen also. It is writing. Yeah, you can take either. Generally, if you see the Jamovi module, they also suggest the Macfadden. We may share one article with you where they are suggesting to use Macfadden over Nagalkar and Cox and Snellen. So yes, you may choose to report one. If you wish that you have to report Nagalkar, you can report Nagalkar also. Up to you. There's no such situation like in this, if this is there, then I will use Nagalkar, or this is there, I'll use Macfadden. Like at least I have not come across, maybe I have not gone through the complete literature of this Macfadden R square. So maybe to answer more accurately, uh, I may require to read the specific literature related to Macfadden, but in general, wherever we have come across through all these three types of R square, we have seen writing or like suggesting that you should use Macfadden. Is it okay?
Okay, ma'am. Thank you.
Okay.
Okay.
So if it is okay, yeah, can someone read this interpretation?
Yes, ma'am. Can I read?
Please, Priyanka.
Interpretation. A binomial logistic regression was conducted to evaluate the effect of various predictors on the likelihood of surgery cancellation. The model was statistically significant with chi-square value of 13. Chi-square 13, that is DF, is equal to 73.99. P-value was significant 0.001, indicating that the predictors as a whole significantly explained the outcome variable. The deviance for the model was 400.42 with an AIC of 428.42 and a BIC of 487.43. Macfadden R square was 0.16, suggesting that the model led to 16% improvement over null model. The omnibus likelihood ratio test identified significant contribution of individual predictors, including gender, p-value significant of 0.011, admission type significant, p-value is equal to 0.014, and a department p-value less than 0.001, anesthesia was significant and surgery was also significant. However, predictors such as age group and days of week were not statistically significant contributors, as the p-value was either equal to or more than 0.05. Collinearity diagnostic indicated no multicollinearity among predictors, with all variables having variance inflation rate factor VIF below the commonly accepted threshold of 10. There was no highly influential point as seen by inspection of Cook's distance. The analysis revealed that males were 2.92 times more likely to experience surgery cancellation than females. Younger patients less than 20 years had 1.93 times higher odds of cancellation compared to the reference group aged 20 to 60 years, while older patients more than 60 years showed no significant difference. Department-wise, general surgery patients were significantly less likely to face cancellation with odds ratio of 0.03 with 95% confidence interval of 0.00 to 0.20, while orthopedics showed no significant association. Inpatient IPD patients were substantially less likely to have cancellation with odds ratio of 0.05. Confidence interval lies between 0.00 to 0.53 compared to outpatient patients, OPD patients. So anesthesia type also played a significant role, with regional anesthesia being associated with significantly higher odds of cancellation. The OR was 0.01 compared to general anesthesia. Lastly, planned surgeries were less likely to be cancelled with OR of 0.51 compared to the emergency surgeries. The classification table showed that the model correctly classified 82% of cases overall. Specifically, it achieved a highly specificity of 99.02 percent
You
correctly.
can leave this because we have not covered this. I will we have planned it to convey this on the day of ROC because we have not told you the ROC, but I'll just show as a command here. And in the above also we have taken like all the variables. If you see this here in the table, we have not included this category wise age. This one, there was a age group category, so that younger and older, if you include this variable also here, then that result will come. We have not taken that variable here. That's why it is not there. So we have just given you a rough this thing how to do that. Depending on your variable, you can take those many predictor variable. And regarding that correct classification, that comes with the option of the prediction. There's an option of prediction you can see here where there is a cutoff point. This is 0.5, which we have discussed that anything 0.5 and more than 0.5 it takes as a positive. And the predictive measure like classification table, accuracy, specificity, ROC curve, if you click this, it will give you the cutoff, the accuracy of this at 0.5 cutoff. So if you click all these, you can see that it will give you the ROC curve and AUC also. That we will discuss once we learn the ROC, but since it has come across in the result section, so I'm just demonstrating it. So if you come here, you can see this is your predictive this thing accuracy. So accuracy is 0.82. That means it is able to correctly identify 82% of the cases. With here specificity is 1 and the sensitivity is very low. And you can see here AUC is 0.75. So generally the acceptable AUC is 0.7. So it has got a good, acceptable level of area under the curve value. And this is the ROC curve. And this is for the cutoff 0.5. If you increase the cutoff, this will change. Everything will change. So that's the overall interface of this. I'll once again show you how to do this. So you can see here there are two types of here you have to move the dependent variable. Here in this table you have to move the covariate or the continuous variable, which is seen by this scale, and this is the factor which is the categorical variable. Then you have to come to the model builder. In the model builder, if you are not going here, I have gone like block wise. It's a type which we discussed yesterday. It was like a hierarchical type of logistic regression where you are entering these in separate block. Else, if you don't want to do that, you can enter everything together and that will be like one type of model. And then you can go to the reference if you wish to change the reference level. Like if you want to see the cancellation in male or female, if you want to change the reference, you can change from here. And then this was the collinearity statistics, which is there to test whether there is a assumption of collinearity, and the VIF should be less than 10. These are the model fit measure. We have seen this deviance, AIC, BIC, and overall model fit. And then this is the model coefficient. Model coefficient is very important because if you don't click that, that odds ratio and confidence interval will not come. And then comes your prediction. And then comes your these values, which we just discussed yesterday regarding the predicted these probability, Cook's distance, and the residual, which we were discussing yesterday. So with this, I think now I will just uncheck this. We should go to the breakout room where you can practice. And again, those of you who could not perform some of the actions like Divya was saying regarding the BMI, you can ask some specific this thing also, basics of Jam movie also. And don't forget to download this survival module, Clinicopath survival module, because from that only you will get that table of adjusted and unadjusted, that means crude odds ratio and adjusted odds ratio together in one table. Else, you can also do like one by one, how we were doing yesterday. And you can keep noting down those values and you can enter that also. Like you can enter only one variable and the dependent variable, and whatever value of that odds ratio and p value comes, you can note it down also. It is up to you how you do that. So any
Ma'am,
question? Yes.
ma'am, I have a question.
Yeah.
Here we took the value p value more than 0.2.
Yes.
Rather than 0.5, it is 0.2. Why these things has happened?
Okay. Yeah. Actually, this we are a little lenient in selecting this our variable, because many times it has been seen that variable which is unadjusted, if it is zero point 0.2, then in adjusted or the adjusted logistic regression, it becomes significant. So if you leave any value which is up till 0.2, then you may miss a significant predictor.
Okay. And ma'am, if I want to put this logistic regression in any of my write-up of a paper, so how far should I write it? What the things that I should keep in the paper? That is the table for the model coefficient table and the likelihood ratio. How far should I?
Basically, the most important is this table, and you have to interpret this table. You should write the assumptions also, at least the assumption of multicollinearity. I have
Okay,
not
ma'am.
seen Cook's distance, but many people they write it also. That assumption you should write, and again you can write about. I mean, you can give this table, and you can only give like single value of r square. So here, if you want to write at least a value of r square should be there. This one and this overall model test. This should also be there.
Overall model test.
If you don't like, you can skip these deviance, AIC and BIC, but McFadden R square and overall model test. And we have shared that template probably. You can use that template
This
here.
template that Dr. Priyanka just before read out. Or this one.
This was the table actually. So this
Okay.
is rough way how you can do that. But again, this is one way. If you want to, like, if you will see many people who give this value of Z and P and everything. Like they give this estimate standard error Z and P like this. So up to you. But again, this is many people you will see that this is the ideal one. Ideal means like in a single table you give the crude and adjusted everything, because that is interpretable and for reader, and then you write about these assumptions. Here you can skip these for AIC and BIC. You can only give the overall model test, significance of overall model test, and you can also give the R square value, a few assumptions, and then you can write about the each level. Again, you will see that in write up many times it's the author choice, but generally the reviewer they say that if it is seen in the table, you don't need to write it in detail. So that's why you just, there are many people they write it like these were the significant predictor as seen by the table in this table, right? So like in this case, I may not, we have written it in detail. Why? Because we also aim to cater to people who are writing the PhD thesis and their MD thesis. Or if you are a guide, then you have to mentor also to the students who are under you. So for that purpose, we have written it little. You can see like it's the length is little more. But for publication, you may reduce this and you may write only one or two line of assumptions, and probably the overall model fit and R square. And even this, you can write only the name of like these were the significant predictors as seen in table 2.
I have another question. One of
Yeah.
my student is doing a thesis on burn patient, and there are some statistical data like the type of burn wound and the ward, something these are there. and the outcome of the patient. Can I make a multivariate logistic regression,
Multivariable. Yes, you can.
bivariate logistic regression
Outcome.
in that case?
What is the
Outcome?
outcome?
One is death and another is cured if I do it
Okay,
like this way.
yes, you can definitely do like all the burn cases. If the outcome you are defining, so one you can write, so you want to predict the outcome of death or outcome of lived one. So depending on that, you can make a model. Yesterday, like we were discussing the minimum number of cases that should have. And if you want
That
to
is
make a
15 in per variable, there should be 15 outcome.
15 outcome, yes. So depending on the outcome, you can make a model and predictor, those many predictors you can take depending on your sample size, and also not only on sample size, but again, what you think, which is important. Like maybe the
I
infection
have to
rate.
I have to check it whether it is significant or not by
Yeah,
seeing the
even if it
p.
is not significant, yeah, you have to check. See, there are two things. There is a statistical significance and there is a clinical significance also. Like many people, they say that even if it is not statistical significance, I want to show it. Then in that case, you can take that variable and you have to write that you think, seeing the previous literature, that this should go into the model.
This such as that the percentage of burn, because percentage of burn has a
Yeah, of course, it is very important. In
okay,
the survival or in the,
death of the
yeah.
okay.
Okay. Anybody else would like to have any query? Okay. If not, then we may go to the breakout room. So, Supriya,
Yes, ma'am.
could you please
Yes, ma'am.
open the...
Yes, ma'am. Opening the breakout room for all the participants.